Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I am Ankit Sir bringing you day 11 of our ongoing series, which is 60 out of 16 KCET maths in 100 days. Okay, so in the first session of determinant we covered only introduction. We learned about what is determinant. Okay, so we said that it is a scalar value associated with a square matrix. Why only square matrix, sir? Because for a rectangular matrix it is not defined. Okay, so we can treat it as a function that operates on a square matrix and gives us a scalar value. So this value can either be real or it can be complex also. Okay, now moving forward in this session, what we're gonna learn? We're gonna learn about minor, cofactor and adjoint of a matrix. Again, what type of matrix? Square matrix. And we'll solve problems on all these as well. And then how is these values gonna help us solve complex problems in determinant. Okay, so this is the objective of the session. So we will make sure that we will learn all these definitions very simply, and then we'll proceed and see how this works in a question. Again, this is a very simple topic, right? How to find minor, cofactor and adjoint, a very simple topic. So today's questions will be very easy. Okay, so actually what happens is you will not have direct questions on this, very rarely, but the application of this concept will be useful in your coming topic. Okay, for example, when you are dealing with inverse of a matrix, then on that topic questions are coming in determinant, right? Inverse of a matrix are given, or you are asked to find it, and then you have to apply properties or theorems of determinant on it. So to find that out, you will need this definitions with you. You need the understanding of all these concepts. So today's concept is basically can be treated as like a tool. The questions might not come on these directly, but the questions can be asked on these concepts. So like on the application of this concept. So let's move on to the first. We'll do the recap. So let's move on to the recap. So if you look at the recap, okay, what is the first thing that we have to look for? So first thing was the definition of determinant. What was this? A scalar value which can be either real or complex, associated with what? A square matrix. So square matrix, so m cross m, not n, m cross m. The number of rows and columns are same. Okay, now apart from this, what we learned? How to determine, like how we find this value, how to find the determinant, how we write it. If for matrix A, how we write? Find determinant A. Okay, so I said we can use either row or column. So we can do any row, we can use any row or column. Whether you do let's say it's the matrix is what? Let's say it is 3 cross 3. It is 3 cross 3. So whether you use row 1, row 2, row 3 or column 1, column 2, column 3, you can use either of these to find the value of the determinant. Okay, so but remember, if you're using row 1, so in row 1 you'll have 3 elements: A11, A12 and A13, right? Then make sure that you are finding for all the 3 elements. Do not use only one element, do not use only two element. So if you are using only row 1, okay, to determine the value of determinant, then make sure that you use all the elements in the row or all the elements in the column if you're using the column. Okay, so but the value that comes out when you use row 1, row 2 or row 3, any value you use, the determinant will always be same. The determinant of A is what? Always same. Okay, then we learnt about methods to find. Let's say we are using row 1. Okay, one more thing we learnt about this, the sign part. Okay, means this is going to be positive, this is going to be negative, and this is going to be positive again. What was the reason? If you remember, the reason was this, bacha, -1 to the power I plus j, -1 to the power I plus j. What is I? The row which is we're taking and the column. So the element will have some row and column, right? So which row value and which column value? If you add that I plus j, if I plus j is what? If I plus j is odd, then you'll have a minus sign. If I plus j is even, then you'll have a plus sign. So this is even, 1 plus 3 is 4, 1 plus 2 is odd, so negative, and 1 plus 1 is again even, so positive, again even, so positive. Remember this? Okay, so scalar value, how to find it using row and column, and this is sign also is very important. We also learned some properties. What we learned in the property part, if you remember, so we learned about this. If there is a matrix raised to a raised to a integral power, positive integral power, and then you're finding determinant for it. Okay, I think this was coming as a power n. So basically, if you have a matrix A of any order, again a square matrix, and you are given to multiply this matrix n times, okay, any positive integral times, then and you find the determinant of that part, then the answer will be equivalent to find the determinant first and then power n. Means if you have to solve this, this will become complex, right? You have to take the matrix and multiply n times. So better to do that is find the determinant of the matrix and then take the power n, because determinant will be a scalar value. You can multiply a scalar value n times. That's not as difficult as multiplying the matrix, right? Then we learned the multiplication is not as same in the matrix for the determinant. So for the matrix multiplication, if you remember, we used to do like this: a into a, right? It will not like first row, then column. So it was not this the case in the determinant. In determinant, it is scalar value, right? Let's say a is coming as k. So if you're multiplying a with a, basically it is k square. Okay, so this is a scalar value, so it can be multiplied like that. No row and column will be involved in that. So multiplication is different. Then we also learned about, if you just look at this part quickly, we also learned about area of triangle, and for that what we wrote, area of triangle from the coordinate plane was given, okay, and we reached this result 1 by 2 if the coordinates are x1 y1 1, x2 y2 1, x3 y3 1. So what was this? x1 y1 was the coordinate of the first vertex, x2 y2 was the coordinate of the second vertex, and x3 y3 was the coordinate of my third vertex. Okay, for a triangle, let's say ABC, for a triangle ABC, the coordinates were given as x1 y1, x2 y2 and x3 y3. If this was the given, then we can find the determinant of this matrix x1 y1 1, x2 y2 1, x3 y3 1, and multiply 1 by 2 it, 1 by 2 to it, then we get area of triangle. Okay, remember this, how we did this derivation in the previous session? If you need to know, make sure that you watch that video and come here to continue from here. Now we also learned about collinearity. Collinearity we also learned, sir. What is it, bacha? Means if there are three given points in the same line, okay, if the points ABC, instead of being like this, if this point B is anywhere above the point C, sorry, if anywhere above the line AC, then it will become a triangle, right? So what I'm trying to say is, if this point B is anywhere above, over here, or over here, below, then what will happen? It will become a triangle, right? But if the point B is on the line AC, if the point B is on the line AC, then what will happen? It will be a straight line called as collinear, So how do we check that? So basically for a straight line, what is the area of triangle? If the point ABC is anywhere up or down, then area of triangle will be some value, okay? Whereas if this point B lies on the line AC, then this part, this matrix here, if you find determinant for it, it will become 0. So this was given like this, if you remember. How was this looking like? This was looking like this. So x1 y1 1, x2 y2 1, x3 y3 1 was given by equal to 0. If this condition is fulfilled for the coordinates given as x1 y1, x2 y2 and x3 y3, then we used to say the determinant, if this is equal to 0, then we used to say the points are collinear. The points are collinear, means lying in the same straight line. So these are the things that we covered in the previous session. I hope you are able to recall this if you have watched the session. So fourth point was this is my fifth point, area of triangle, and sixth point was collinearity. Okay, few more things we must have studied in the previous session. So go ahead, watch the video and then come for this session. Okay, continuing forward for this session, as I said, in this session we'll talk about minors, cofactors and adjoint. Okay, so what is a minor? Let's look at the first definition. What is a minor? So what are minors? Okay, so let me write a matrix for you first. A11, A12, A13, okay. So what is this? This is a matrix of what type? Square. Order is 3 cross 3. Order is 3 cross 3. Let's name the matrix as A. So for this matrix A, if you consider any element, what? Let's look at this, Aij. For any element Aij, so I can take this also. So for this element Aij, if you eliminate the row and the column which is containing this element, means if I remove this row and this column, then what is left? Only this part. Then this will be my minor bacha. Okay, so the minor across my element A11, okay, will be this. So you can see from here, for the element A12, I'll have a different minor. How, sir? Because for this case, then I will remove this column. For A12, for the element A12, I will not have this column because A12 is contained in the second column. So for the A11, it was contained in first row and first column. So I removed the column 1 and wrote this part as my minor. So if I have to write respect to A11, forgive me, A11, I can write my minor as what? That's my minor, okay? And how we write this, how we represent this? Like Mij. So this is going to be basically my M11. Why M11? Because we are writing with respect to A11. So the minor with respect to A11 is given by M11, okay? So the minor with respect to A12, so it'll be M12. And how will you write this? What value that be? It'll be A21, A23. Please check here. A21, A23, because I have removed the first row and second column now. Why that, sir? Because A12, the element A12 is contained in the first row and the second column. So same way, if I go ahead and understand only for A13, then I'll remove what? Third column and first row. Okay, so wherever the row, wherever the element is contained, that row and column has to be neglected. So if I do that for A12, I'll write what? A21, A23, A31, A33, A31, A33. This will be my minor across the element A12. So I write it as M12. I hope this is clear. I hope this is clear. You can see this, right? You can see this? Okay. Alright, sir. Moving on. This is for minor. Let's see. So in determinant, how many, if the order is 3 cross 3, how many elements are there? Check here, please. How many elements are there? 1, 2, 3. Total 9 elements. How many elements are there? 9 elements are there. Then I am writing this minors across each element, no? A11, A12. Okay, this is across A12. Same way I can write across A13. I can write across A21 also. And remember, minor across each element will be unique, right? For A11, this is value might be same. Value might come as same because the number will depend on what is the element value. But if you see the minor, how it is coming, from where it's coming, so for this it is this one. Okay, then it will keep changing for each element. It will keep changing for each element, right? So if you look at, let's say A33, if you look at this element, what will be my minor? So you'll remove this, and what is left? This will be my minor. Okay, I hope you understand that. For the element A33, my minor will be A11, A12, A21, A22, A21, A22. Okay, so let me erase this part. Okay, all right, let's move on. So you get 9 minors actually. Get what? 9 minors will be 9 elements of the determinant, because there are total how many elements in 3 cross 3 matrix? 9 elements. Okay, now this is all pretty obvious. If you have for the element Aij, if the determinant order is n, in this case what is the order here? N was 3, sir. What is the n here? N is 3, sir. Then check the order of the minor. It's 2, no? This is 2, right? So if the order of the determinant is 3, then the order of the matrix for the minor will be 2. So that's what it's saying here. If this is n, then this will be n minus 1. This is for what? For my minor. This is for my minor. So minor will have a order. Minor will have order n minus 1. Where what is n? N is the order of determinant. N is the order of determinant. Okay, sir. Moving to now cofactor. This was it in minor part. This was it in minor part. We'll solve some question on it, but let's look at cofactor. Cofactor will be same thing with the minor, but you have to include the sign also. Sir, what sign? Remember the signs how I always talked about this? So for this, I can write positive. A11. A11 is what? I plus j is even, so positive. A12 is negative, A13 is positive. Same way A21 is odd, so negative. So if I have to write this again, let's see here. You have to write the sign. Check again this. A11. This is my positive, this is negative, this again is positive, this again is negative, this is positive. What, sir? A2 plus 2 is 4, 2 plus 3 is odd, so negative. 3 plus 1 is positive, because even, odd here, negative, even here, positive. So if you are writing, simply if you are writing the minor or the cofactor for A33, not minor, cofactor for A33, forgive me, then you have to take this as positive. If you're writing for A32, if you're writing what? Cofactor for A32, how will that look like? It looks like this, A32. Element looks like A32, right? But cofactor symbol is A32. We write capital A. If you're writing this, then what will happen? Just simply write minus sign because this is negative and write M32. So write the minor across 32, okay, element A32, and put a negative sign next to it. So that's what it is. So see here, Mij with the sign part as well. So when you do that, you get your cofactors. That's all for this. Okay. Now, if you are doing expansions, means what? If you're trying to do expand and find the value of the determinant using cofactors, you can find that. And how does that work? So look at here. If I find the determinant value, this symbol represents what? Determinant. This symbol here represents determinant. Okay, this triangle symbol represents what? Determinant. So if I find a determinant across which is this? A11, A12, A13. Check here. A11, A12, A13. I'm finding across my row 1. Okay. So you have to take what? That's what we used to do, no? For A11, we used to take this to find determinant. So this is my what? Cofactor of 1. Check here. Cofactor of 1, first element. This is my cofactor of second element. Cofactor of third element of which row? Of row 1. Okay. Same way if I go to row 2. I can find using row 2 the first element of row 2 with cofactor of row 2 first element, the second element with its cofactor, third element with cofactor. Means you take any row or any column, okay, take all the 3 elements if it is 3 cross 3 matrix and multiply with its respective cofactors, not minors, respective cofactors. Sign will also be true. If you try to match with our original method which we used to do, no, expansion across row, the value will come same. Actually operation is designed from that part only. So we used to do, no, 3 cross 3 matrix. We are taking this element, so we'll cut out all of this and take this. Okay, that's nothing but that's what you used to do, multiply this and this. So same thing is the minor, right? This is the same minor, no? And if you take the positive sign for this, it becomes cofactor. If I am doing this element, I should consider a negative sign. So same operation is there for finding determinant, but we are trying to write in terms of cofactor. Okay. Now, one very important part. So this is for row 3 again. A very important part. If you are multiplying an element A1, so let's say I should do A11 plus I have to do A11 only, means the element A11 with the cofactor of the same element. Okay, that's what I've done here, A12, A13. But if somehow I take something else, now what else? Anything different. So if A11 is multiplied with other element and taken like this, so A11 multiplied, check here, A11 with A21, A12 with A22, A12 with A22, A13 with A23, means this element and the cofactor are not corresponding to each other. The element and the cofactor are not corresponding to each other. Whenever this happens, your determinant or this whole expression will become 0. Okay. If you multiply the element with not the corresponding cofactor, then the value of this product will be 0. Whether you take for any row or any column, okay? You take across any row, row 1, row 2, row 3, or column 1, column 2, column 3. If you're not taking the corresponding cofactors, then value will be coming as 0. That's what written here. In a determinant, the sum of product, this is sum, right? Sum of product. Product of what, sir? The elements of any row or column with the cofactor of any other row. Means you are taking an element from some row. Let's say I am considering row 1. I am taking cofactor for any other row. Let's say row 2. Then answer will be 0. This sum will come as 0. Okay. This sum of the product will come as 0. I hope this is clear. Okay. Moving on. So first problem. Okay. This is based on definition only. I hope all of you can answer with me. No need to pause the video or take some time to solve this question. So if you take the first one, please look at here. The first one. What are they asking? Find the minors and cofactors. Find the minors and cofactors. So if I find just cofactor, you will get the minor, no? Because what is cofactor? This is nothing but Aij given by minus 1 to the power I plus j Mij. So if I find the values, over here I'll find only values of Aij. From there you can find the minors. Okay. So let's see. For my A value, okay, for element A11, okay, what is the minor? So if I have to write directly for this, I'll do one of them in all the steps. So my minor will look like, M11 will look like what? Just this D. Please check here. Just this D. So write D. Okay. Now what about sign? I'm writing, let's say, A11 now. I hope you are able to understand this. They are all three different things. A11 represents element, M11 represents the minor, and capital A11 represents my cofactor. So if I'm writing cofactor, so D will come, obviously. The sign will be what? Positive, because 1 plus 1 is 2. So positive, so plus D only. So my A11 is simply equal to plus D. What about A22? Look at here. A, not 22, A12. A12, look at here. A12 is where, bacha? Here. My C is A12. So if you look at C, what is the minor here? B. So B I will write. 1, 2 means what? Odd. 1 plus 2 is odd. So it will become negative. Please check here. 1 plus 2 is odd. So it will become negative. So answer is what? Cofactor is minus B. What about A21? A21 is here, bacha. So A21 is C. Forgive me. A21 is C. For A21 I'll have C. So right here C. Odd, so negative. 2 plus 1 is negative. Odd, so negative. And what about A22? For A22 I'm considering this element D. So there will be nothing but A. I hope you are able to understand why, sir. If I consider A22 means this and this will cancel, right? I will not use this row and column. So only A is left. So I'm writing here what? A. What is the sign? Positive, sir. How positive? 2 plus 2 is even, so positive. So my cofactors for the first matrix which was given, okay, is nothing but A11 as plus D, A11 as D, A12 as minus B, A21 as minus C, and A22 as plus A. Now what about this? Let me write this matrix in the next, this determinant on the next page. A104, 10435 minus 1. So 10435 minus 1. What else? 012. Okay. Now if I have to find for every element, if you have to find, how will I find this? So some we can find over here only, we have enough space. So let's see. This is I'm doing for part 2. Please check. So for this element A11, I'm writing for A11. Cofactor across first element of first row. How will this look like? So positive, because 1 plus 1 is even, so positive. What about this? Simply 5 minus 1, 1, 2. 5 minus 1, 1, 2. Because we're gonna eliminate these two. Only this part is left. So 5 minus 1, 1, 2. Okay. See this here. So what is my answer? Simply check here, 5 2s are 10 and minus of minus 1, so 11. So my A11 is 11. What about A12? A12, I will consider this and this, okay? So A12 is across the element A12, so this will be nothing but negative sign because 1 plus 2 is odd, 1 plus 2 is odd, so negative sign will, what will this? It will be 3 minus 1, 0, 2, 3 minus 1, 0, 2, okay? 3 minus 1, 0, 2. How will this look like? So 3 2s are 6 and this will be simply 0 because 0 times minus 1 is 0. What is the answer? Minus 6. Please check. 3 2s are 6 and this is 0. So answer is minus 6. What about A13? So in this case, we will consider what? We will consider the last column with the first row. A13 is this element. So the cofactor will be across the same element. So I will consider what matrix? 3 5 0 1. So what will be the sign? Please tell. 3 5 0 1. Sign will be positive, sir, because 1 plus 3 is even. 1 plus 3 is 4, which is even. So plus sign will come only here. Okay. How will this look like? I forgot to write 0 1. 3 5 3 5 0 1. Okay. So it will be 3 times 1 is 3. 0 times 5 is 0. Answer is 3. Answer is 3. Okay. So A13 we also found. So let me do for second row quickly. If I have to show for the second row, how will this look like? So I can go like this and this for the first element. So my A21 will look like this. 0 4 1 2. 0 4 1 2. What is the sign? 2 plus 1 is odd, so negative. How much is that? 0 minus 4. How much is that? Minus of minus 4, which is nothing but plus 4. Nothing but plus 4. Okay, this is plus 4. What about A22? What about A22? In this case, please check. In this case, we'll cancel these. A22 will be this. Okay, so what is left now? It's even. 2 plus 2 is even, so positive with what? 1 4 0 2. 1 4 0 2. What is the answer? 2 minus 0. How much is that? 2. 2 times 1 is 2. 0 times 4 is 0. Okay, 0 times 4 is 0. So 2 minus 2. 2 minus 0 is 2. Same way you can do for A23. A23. And same way you can do for A31, A32, A33. Okay, please solve these. Please solve these. Okay, same method. Wherever is that element present, cancel that row and column and take the matrix accordingly and find the determinant with the sign what? Whenever it's even, positive, or then negative. Okay, I hope you can get it, right? Let me move on to the next question, sir. Find the cofactor of the element A12, A22, A32. Okay, so here what is given? In the case of trigonometric function they have given. So are they difficult, sir? Of course not. Of course not. Check. Please check. Where is my A12? So my A12 is here. This is my A12. This is my A12. Correct? A22. A22 is this, bacha. A22. And where is A32? A32 is this. So basically what they are saying is, find the cofactor of all the elements in second column. Find the cofactor of all the elements in second column, right? So I can just erase all of this and mark entire column. They are asking us to find the cofactors of all the elements in the column 2. In the column 2. Difficult, sir? Of course not. Let's see. So if I am finding the cofactor, I will write like this directly. A12. A12. Correct? A12. How will this look like? A12. Please check. If I am doing A12, this element, what will I cancel? I will cancel. Second row, second column is to cancel. For the first element, I will cancel the first row. So that will give me this, 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 this. So how will the matrix look like? First write the matrix, then we'll see the sign. So minus sine theta. Please check. Please check. Minus sine theta. This is plus sine theta. This is minus 1. And this is plus 1. Okay. Now A12 means odd or even? Sir, odd means negative sign. Please simplify. This is going to be minus sine theta. And this will be what? Okay, sir. This will be what? Again, a minus of minus. So minus of minus sine theta. How much is that? Simply plus. So this will cancel each other. Plus sine theta minus sine theta is cancelling each other. So 0. So my A12 is 0. Check here. Which option give me? Only this option. A12 is 0. Why like that, sir? They have given in order, no? Respectively, they are saying. Means in order. So answer is directly this thing, 0, 2 minus 2 sin theta. If you want, we can solve and find other elements also. We can find for A22. So for that, I will not consider which row. I will not consider row number 2. Why, sir? A22 is this element, no, 1. So I have to cancel the second column, okay, but second row also have to cancel. What's the matrix gonna look like? Positive, sir, because 2 plus 2 is even, so positive, sir. How will the element look like in the matrix? So 1, 1, okay, and minus 1, minus 1. So minus 1 and plus 1, forgive me, minus 1 and plus 1. How will this look like? So 1 into 1 is 1, and minus signs 1 into minus 1. Okay, how much is that? 1 plus 1. How much is that? 2. So 2 check here. 2. Second element is 2. Second element is 2. Second element is 2, bacha. Okay. So I hope you can find the last also. Let me see if I can do it for you. I should be able to do it for you. Okay. So I will cancel this and the last row. So what is going to be my matrix for A33? For A33, not 33, A32. A32, right? This is A32. Cofactor for this is A32. So it will be nothing but 1 1 minus sign plus sign. Okay, 1 1 minus sin theta plus sin theta. Correct? Please check. 1 1 minus sign plus sign. Okay, and what is the sum here? Odd, sir. Odd means negative. Please check. 1 into sine will be sin theta simply. Okay, and this will be nothing but my minus of minus sin theta. How much is that? Minus of 2 sin theta. How much is that? Minus 2 sin theta. Please check. Minus 2 sin theta. Answer is correct, sir. So option A is my right answer for this. Option A is my right answer for this. Moving on. Question number 3. How will this look like? Find the sum of cofactors. Means you have to find the cofactors first and then take the sum. So basically, how will the cofactor look like? A11, A12, A21. Doesn't look like 2 and 1, sir. Okay, sir. A21 and A22. Right, bacha? Yes. A11, A12, A21, A22. Okay, sir. Okay. So if I'm doing for A11, this is considered only 3 is there. A11 means positive, so plus 3. Okay. What about A12? So for A12, I will remove this and this. Only 4 is considered, so 4. Since it is 1 plus 2 is odd, so minus sign. Okay. Simple question, sir. I said this will be a simpler topic. Okay. Not questions you can expect. Maybe if they want to frame a question on this, they can ask, but you can expect questions on the application of these concepts. Okay, not directly. Now A21 is this element. So what is left? Minus 2. It is odd again, so again I'll take a minus. It'll become what? Plus 2. Okay. What about A22? For A22 I will remove this. How will this look like? A22 will be this. So what is the answer? Simply 1. It is positive because it's even. 2 plus 2 is even, so positive. Now they're asking sum of it. They're asking you what, bacha? A11. That's what they're asking us. Let's do it. Correct? 3 plus minus 4 plus 2 plus 1. So this is 3 plus 1, which is 4. So this and this will cancel each other. So answer is 2. Option number A. Option A is your correct answer. I hope you can see that. Please check, sir. Okay. All right. Okay. Now, adjoint. So, minors and cofactor, I think you don't have any doubts. They're simple concepts, not that much difficult to understand. Now, adjoint of a square matrix. Again, all these properties are valid only for square matrix. Okay. So, what happens in... So, if a matrix is given like this, so what happens in adjoint, no? What happens in adjoint? This is a matrix, A11, A12. This represents element. This is nothing but the elements of the given matrix A. Now, what you do is, you write the cofactor across all the elements. So the cofactor across A1 will look like this, A11. Cofactor across A12 will look like this, A13 will look like this. Correct? With the sign obviously. So A11, A12, A13. Means you have to make a matrix now with what? All the cofactors across corresponding elements. Now once you made this, take transpose. Means what? Take this transpose. So this you get here and vice versa you move this here. Okay? This you get here and vice versa you move this here. Okay, same way this you get here and vice versa this. So apart from the diagonal elements you move, or what do you call, upper triangle will become lower triangle and lower triangle will become upper triangle. So once you do that, see here, A12 has come here, A21 has gone up, A31 and A13 is interchanged. So interchange these values, this will be your adjoint A. Okay, so first you start from the element of the matrix A. Again this has to be square matrix. So 3 cross 3, then you find all the all the cofactors across each elements. Once you do that, transpose that value. So basically this is transposed. Once you do that, you'll reach a matrix that will be called as adjoint of A. So basically adjoint of A is going to be a matrix of same order. Please see. So you started with 3 cross 3 matrix and you reached also where you reached adjoint of A, and it is of the same order square matrix. Okay, so adjoint will be a square matrix only. Alright, so moving on, same thing is written here. Let Aij, what is Aij? Elements of the square matrix. Okay, of what? Order n. Then Aij will be cofactor. Okay, across the element Aij for the matrix A. And how you get it? By taking transpose of the cofactors. Okay, taking transpose of the cofactors. So not much is there. All right. So let's see. This is a matrix defined as A, B, C, D, 2 cross 2 matrix. They are saying this is my adjoint. So again you can see 2 cross 2 matrix. So let me do the middle step. They are saying that for the given matrix A, adjoint A looks like this. I am trying to do your intermediate part. So first, what was the step? Remember this. From the element Aij, we used to go to the cofactor Aij. So let's find the cofactor of this first. I said this. So I'll find this as, how will this look like? If I'm doing that, how will this look like? So for the first one, A, for this one, only D will come. But what about positive or negative sign? First one is always positive, so positive. For this one, for B, this C will come. But with what sign? Negative sign. I hope you understand that. Let me explain it to you one more time from the top. So for this B, I'll remove these two. Okay. The C is left, so C will come as cofactor. Okay. What is the sign? This is 1, 2, right? Element name is 1, 2. So 1 plus 2 is odd, so minus sign. Same way for C, for this one, I'll get what? B, again with minus sign, because what is it? 2, 1. So again odd. What about this? I'll get simply A. Now order say, take transpose. If you take transpose, what will happen? D and A will remain at the same place. This C will come here, so minus C. This B will go there. So this. Please check. D minus B minus C A. This is my adjoint A. I hope you understood this. This is the intermediate step I was talking about. Okay. Okay. I hope this is clear. Bacha. Okay, sir. So I took example and I tried to explain you how this actually works. So what is actually adjoint and how do you get the final answer using your intermediate step. Okay. Now, very simple concepts, but this is very important because this is a base for your next session, which is going to be very difficult, and not difficult, basically the questions will be asked from that session. Okay. Means those concepts will be used to answer directly questions from your KCET examination. Inverse, you know that inverse of a matrix questions are coming. Okay. So if the questions are coming on that topic, means you have to answer it. Okay. And for that you need to know the adjoint, singular, non-singular matrix, all this. These are simple definitions only. So we'll quickly cover them. Okay. Singular matrix. On these questions can be asked. Okay. But if they are asked, good for you. Very simple. So if the matrix is singular means determinant will be 0. Okay. Determinant of the matrix will be 0. Again we are talking about only square matrix. Okay. So if, again, what is other part? If it is not equal to 0, then the matrix is non-singular matrix. The matrix is non-singular matrix. Okay. Now the examples have been taken here. So if a determinant of A is, two conditions are there, equal to 0, then singular matrix, not equal to 0, non-singular matrix. Okay, sir. Now checking here. So A is given as 4, 1, 16, 4. Check here. 4 into 4 is how much? Matrix, we are finding determinant here. 4 into 4 is 16. What about this? 16 into 1 is what? 16. What's the difference? 0. So what is it? A singular matrix. It is a singular matrix. What about this? B. Check here. 1 into 5. 5. What about this? 3 into 2? Minus 6. Okay. The sign is negative here. So minus 6. What do you get? Minus 1. Which is not equal to 0. Hence non-singular matrix. Yes sir, it is that easy actually. Okay. Moving on. Now we have some theorems for it. We have some theorems over here which will be very important to know because this will be used in inverse of a matrix. Okay. Looking at them one by one. What's theorem 1? If A is any given square matrix, okay. A is any given square matrix, that's a basic definition, sir. Why are you repeating all the time? Yes, it is important, that's why I'm repeating all the time. Then the property is this. A adjoint A. Okay. A adjoint A is equal to adjoint A means you first take the matrix A, then multiply it with adjoint of the matrix A. What is adjoint of the matrix A? First you take the cofactor and then you take transpose. So when you do that, when you multiply the matrix with the adjoint A and then you multiply adjoint with the matrix A. I remember that I said this. Adjoint A is also a matrix of the same order, so you can multiply that, right? So A cross A, if you do like this, A cross adjoint A or adjoint A cross A, you'll get what? Determinant of A. You'll get determinant of A, which is scalar value times identity matrix. So basically, so it will come as some number, let's say K times of like this 1 0 0 0 1 0 0 0 1. If this n value in this case is let's say 3, if this is a 3 cross 3 matrix and you're multiplying what? A matrix, the matrix with the adjoint of the matrix, or you're multiplying in the other order, you'll get what? A scalar value multiplied to it because determinant is a scalar value with the identity matrix of the same order. So correct, 1 0 0. Obviously no, this we know because product of two matrix will be what? A matrix only, no? So I cannot just write determinant, no? Because then it's not a matrix, but IN is a matrix of order n. It's a matrix of identity matrix of order n. If n is 3, it'll look like this, bacha. I hope you understand that. So this is theorem 1. We will use this theorem to prove our inverse. So important. What about this? If A and B are non-singular matrices of same order, what is the meaning of this? That's what it means. Non-singular means A not equal to 0. Non-singular means what? A not equal to 0. Check here. Non-singular, A not equal to 0. Okay. Too many lines, sir. Alright. Okay. So if A and B are non-singular matrices of same order, means what? Again, order has to be n, whatever it is. Then AB and BA are also non-singular matrices of same order. Of course, right? If you multiply A and B, the matrix A and B, you'll get what? Another matrix. Let's say this matrix C you'll get. Okay, the matrix C you are getting. Again, it will be of same order. So this we have learnt. If this is of order n, this is of order n, this is of order n. Why this is true? Because square matrix again. Square matrix. Then if it is non-singular, A and B, then this will also be non-singular. This will also be non-singular. What is it? The result will also be non-singular. Okay, I hope you understand this. Okay, we'll see the practice. We'll see in the practice questions. Theorem 3. A determinant of the product of matrices. Theorem 3, sir. Okay, so we have covered up so far. What we have learned so far? 2 part. So one thing was this: A adjoint A or adjoint A times A is equal to the scalar or determinant of A times identity matrix of the same order. Second one was if A and B are non-singular matrices, then product will also be a non-singular matrix. So 2 theorems are simple, sir. Okay, now what about this? Theorem number 3. Okay, again A and B are square matrices. Then what happens? Product of matrix you take and then you take the determinant is same as determinant times determinant of the 2 matrices. Okay, so determinant of A times determinant of B. Okay, that's it. Now what about this? if A be a non-singular matrix of order n, then this. If you find determinant of adjoint A, it will simply come as determinant of A to the power n minus 1. Okay, what is n here, bacha? N is the order. N is the order of square matrix. Square matrix. Okay, so what it's saying? If you find adjoint of A, how do we do that? Take the elements of A, find all the cofactors across each element and take transpose of that. If you do that, you'll get a matrix of the same order, and then if you take the determinant of that, it's simply nothing but this will be a scalar value, correct? Then this will be taken as the determinant of A to the power n minus 1. If you get these values, the answer will come as same. We'll see in the questions again. Okay, all right. Let's now coming to the questions part of the session. Okay, now we'll solve some questions. Minor of an element of a determinant n cross 1. Okay, so if let's say I have a matrix, okay, or determinant given like this, 3 cross 3, 3 cross 3, then obviously the minor will be what? Minor will also always be 2 cross 2 only, no? We saw that, right? So if I was considering this element, this was cancelled, I had this as my minor. For any other element for 3 cross 3 matrix, I had minor as 2 cross 2 only. So that's what I'm saying. If the value of the order is n, then the minor order will be what? N minus 1. The order of the minor of the element will be 1 minus 1. Okay. All right. The order of the minor will be what? N minus 1, sir. Simple question. Only on definition based. So let's read all the statements. Which of the following option is correct? Only we are looking for correct answers. Only we are looking for correct answers. Okay. So for the given determinant A, determinant of matrix A, which is nothing but 3 cross 3, order is 3 cross 3, sir. It is a square matrix with order 3 cross 3. All right. Let's check. First one, order of the minor is more than order of the determinant A. This is incorrect, right? We just said order of the minor is 1 less than the order of the determinant A. So this is incorrect. Order of minor is more. Not possible. Not possible. So incorrect, sir. Second one, minor of the element is always equal to cofactor of the element. Not necessarily. So it is equal at times only when it is positive sign. For the negative sign, when we consider this minus 1 to the power I plus j, this factor will come, right? So not always equal. Not always. It is equal at times but not always equal. Okay. I hope you understand that. So minor and cofactors are not always equal, sir. Not always equal. All right. So B is also incorrect. What about C? Cofactor of an element Aij, for the element Aij, cofactor is obtained by multiplying. Yes. We multiply. When we multiply this part minus 1 to the power I plus j, which gives us the sign part of it, then we get our cofactor. So option C is correct. Option C is correct. Let's check option D anyway. So value of a determinant obtained by only multiplying element of a row or column with the corresponding cofactors. Okay. So if you look at this statement, it seems right, no? Everything is right, correct, sir? Determinant value, if you are finding out, if you multiply the corresponding element with row and column with the corresponding cofactors, it is a determinant, right? So if you are looking for this, if this is element A11, then if you take this cofactor and multiply this cofactor with this element for all this thing, you'll get it right. That's your answer. But they're saying only multiplication is incorrect. You have to add these also. So this is basically sum of the product. Sum of product. What I mean by this, it means the determinant of A will look like this. A11 is there. A11 is with this. So means the element with the cofactor plus again next element with the cofactor and cofactor. Okay, means the summation of the product has to be there, not only multiplication. Summation of the product has to be there. So that's why option D is incorrect. Only multiplication is incorrect. You have to add the multiplication together as well, like this. So option C is your correct answer. I hope you understood this. Option C is correct answer. Means to get the cofactor, you multiply minor with this sign convention, minus 1 to the power I plus j. Let's move on to question number 6. Okay, adjoint of A, for the matrix A, what's the adjoint? The transpose of cofactors, right? We used to write the cofactors first. Remember this, A11, A12 and so on like this. And then we check what? Transpose. Okay. So transpose of cofactor again for only square matrix. Transpose of cofactor. Option B is correct. Option B is correct. Moving on. So let's look at this question. If 2 plus x, 3, 4, 1 minus 1, 2, x, 1 minus 5. This is nothing but my 3 cross 3 matrix. Let's name this matrix as A. So matrix A is given like this. Is a singular matrix. Means what? This is equal to 0. Determinant is equal to 0. Then find the value of x. Okay, then find the value of x. Let's quickly find the determinant. So how will the determinant look like? A will look like this. So for if I do the expansion across first row, so this will be 2 plus x, positive sir, okay, times what? I'll cancel this and this. Minus 1, 2, 1 minus 5. What about the second one? If for this will be negative because A1, 2, so minus 3 with what? I'm going to cancel this now in this case. So this will look like what? 1, 2, 1, 2 and x minus 5 and x minus 5. Alright, so moving on please. For this one, for the last element which is 4, will be positive, right? This will be positive, so I'll take it as plus 4. Again cancel the last column. This will be what? Giving me the matrix as 1 minus 1 x and minus x and plus 1, x and plus 1. So please forgive me. Okay, let's move on to the simplifying this part. This will look like 2 plus x, 2 plus x, 2 plus x. And what bacha? Multiply this 5 into 2. How we do this? This times this minus this times this. So minus 1 into minus 5 will look like 5 and this will be simply minus 2. What about this? Minus 3 times of minus 5 and minus 2x. Correct? Minus 5 minus 2x. What about this? Plus 4 times of 1 minus of minus x. Correct? 1 minus of x into minus 1. So minus x like this. Okay, moving on. So 2 plus x times what? 3 is there. So let's multiply 3 here simply. And minus 3 times of minus 5 will be plus 15. Minus 3 times of minus 5 is plus 15. Minus 3 times of plus 2 x will be plus 6x. Okay, sir. This will be plus 4. 4 times 1 is plus 4 and this plus x. So plus 4x. Plus 4x. Alright. So let's simplify it over here only. The last step. So this will be what? 6 plus 3x plus 15 plus 6x plus 4 plus 4x. 4 plus 4x. Let's add all the x values first. So I have 3x plus 6x, which is nothing but my 9x. 9 plus 4x is 13x. 9 plus 4x is 13x. So let me write it here. 13x. Please cross check again. 6x plus 4x is 10x. Plus 3x also you can do 13x. Okay. What about the numbers? 15 plus 6 is 21 plus 4 is 25 plus 4 is 25. They have given what? Singular matrix. So A is equal to 0. A is equal to 0. This is equal to 0. 13x plus 25 is 0. Minus 25 equal to 13x. So x is equal to minus 25 by 13. Okay. Please check. X is option D. So option D is my correct answer. Simple, very simple. Let's move on. Looking at this question, okay, so they have given the determinant of, sorry, they have given the matrix A as 3 cross 3 matrix, a square matrix again of order 3, and they are asking us what? Determinant of adjoint of A. So basically, find the adjoint first and then find the determinant. That's what they are asking us, correct? We know this formula simply as k minus 1. Simply as k minus 1. This was there in the property. Okay, theorem. We did this somewhere, it was written. Yes, check here. Adjoint. The determinant of adjoint of A is nothing but matrix or determinant of A to the power n minus 1 to the power. Please check, it's not visible. Not visible. Let me rewrite it here if you want me to. This is nothing but determinant of adjoint A is equal to, find the determinant of A and then power minus n minus 1. Power n minus 1. Please check here. Okay, I've written here already. Sorry. So coming to this problem now. So that's what they are asking us. Okay. And you have to use this formula. So what is the order here? What is my n value here? N value is 3, sir. N value is 3, sir. So I can simply write this as determinant of A. If I find this as 3 minus 1 will become determinant of A to the power 2. How will the determinant look like? Please check here. Determinant will look like this. A 0 0 0 A 0, okay, and 0 0 A. Am I right? 0 0 A. All right. Now let's take across first row. So A will be with what? This one, A 0 0 A. Rest all is 0. Because if we multiply with 0, so this is negative sign. Forgive me. This is minus 0 times anything is 0, plus 0 times anything is, this is minus, is plus, this is plus. So minus 0 times anything is 0, plus 0 times anything is 0. So I don't have to consider that. What about this part? The determinant of A will look like A times of A square. A times A is A square minus 0. What is the answer? Simply A cube. Simply A cube, not 9. Simply A cube. So I can put it here as A cube, right? No need of determinant anymore. A cube square, how much is that? A power 6. So I got the determinant value as A cube. Square of that is A power 6. Option number C. Option number C. Answer is what? Answer is C, bacha. Answer is C. Simple, simple. Moving on. If P is a matrix of again order 3 cross 3 square matrix, they're saying adjoint of this. Okay, this given matrix is a adjoint of a matrix A. Means there is a matrix A, and for that I can write what? Adjoint of matrix A. Adjoint of matrix A is equal to what? P. Please check. Please check. Let's read the statement again. If P is the adjoint, so P is the adjoint of what? Of the matrix A. Of what order? 3 cross 3. What is the order here? 3 cross 3. And this is also given. What is this? Determinant of A is 4. They are given determinant of A is 4. What do we know? What do we know? If I find determinant of adjoint of A, please check here. If I find determinant of adjoint of A, I can simply write this as determinant of A to the power n minus 1. Now please check. How is this going to help us? Do we know adjoint of A? Yes sir, P. So instead of adjoint of A, I can write it as P. And this will be what? This is simply 4. What is n? 3 minus 1. Simply how much? 4 square. How much is that? 16. So check here. P is an adjoint of A. So I have written here adjoint of A is P. We know this property. Determinant of adjoint A is equal to determinant A to the power n minus 1. So adjoint A is nothing but P. So I wrote here as P. Correct? This is given as 4. So 4 power 3 minus 1. 3 is the order. 3 minus 1 is 2. So 4 square is 16. Now check here. P you know in terms of the variable alpha. If I find this P determinant, I'll get a relation in alpha. I have that equal to 16. I can solve it. Please check. Please check. So let me write this matrix. 1 alpha 3. 1 alpha 3. 1 3 3. 1 3 3. 2 4 4. This is my P. So determinant of P will look like what, bacha? Please check here. It will look like, if I do across 1, so I get 1 times of what? 3 3 4 4. What about alpha times if I do? This is plus, this is minus, this is plus. So minus alpha times what I'm gonna get? I'll cancel this and this. So I'll get what? 1 3 2 4. 1 3 2 4. Correct? Correct. Now what about 3? If I do across this number 3, then I'll cancel this part. Correct? For this element. So by now you all know how to find matrices. So plus 3 times of what will be left? 1 3 2 4. 1 3 2 4. Let's quickly find this determinant value in terms of alpha. So I can continue this as is equal to 1 times of what? Check here. 12 minus 12. How much is that? 0. Correct? Over here what about 4 minus 4 into 1 is 4, and this is minus 6. 3 times 2 is 6. This is 4 into 1, and this is 2 into 3. So 6. And what about this? What about this? Please check. This will be 3 times of 4 minus 6. This will be 3 times of 4 minus 6. Correct, na? 1 into 4 is 4. 2 into 3 is 6. So minus 6. Okay. So this is simply 0 because this is 0. Alright. Minus alpha times minus 2. Correct? 4 minus 6 is minus 2. So this will be simply 2 alpha. What about here? Again, this will be 4 minus 6. So minus 2 times of 3. So minus 6. Please see. 3 times of minus 2 will be what, bacha? Minus 6 only, no? Correct? Alright, sir. Yes, sir. Yes, sir. Yes, sir. Okay. Let's simplify. So I get 2 alpha minus 6. This is given as 16. Check here. 16. Determinant P is equal to 16. We got from the result that is given in the question. So bring this 6 over here, it becomes 16 plus 6 equals to 2 alpha, right? So this is 22 by 2 alpha, sorry, by 2 is equals to 11. Alpha equals to 11. Any answer matches this? Option A. Option A. Option A is my answer. 11 is my answer. So this was it for the session. Okay, simple session. Nothing much was there. Very simple concepts. All the questions are also easy. Tomorrow's session, which will be on inverse of the matrix, will be a good session. You'll have a lot of questions. Calculations will also be there. So make sure that you have all these concepts from the first 2 sessions with you. You understand everything in it. Then you can move forward and solve all the questions of inverse and the questions coming in your KCET examination. Right? Alright, with this I would like to conclude the session today. I'm going to see you in the next session. So make sure that you're working really hard and keep smiling all the time. Okay, whenever you can, be positive. Okay, so that's it for the session today. Take care. See you in the next session. Bye-bye.